I'm going to talk to you about integrating systemd-sysupdates and Yocto. So, who am I? I'm Emanuele. You can read there. I work at Igalia inside the core team. And I'm, generally speaking, probably well known as a GTK and GNOME developer. I'm occasionally an application developer. I've been doing this stuff for 20 plus years. I don't know how many people here are familiar with Yocto, so I just describe it a little bit. Yocto Linux is a Linux Foundation project that is used to create Linux-based operating system images. It has multiple features. The most important one is probably, that is pretty much the industry standard. It is an evolution of the open embedded project, like from 20 years ago. It evolved into the Pokey Linux project, which was kind of a reference environment, and then it got folded into the Yocto brand a while ago, first at Intel and then at the Linux Foundation. It gives you nightly builds, LTS releases with security updates and things like that, so you can build your own operating system image using a vast series of dependencies and recipes for it. And yeah, it's pretty much the Swiss Army bazooka of build systems. And if you're just building an operating system image, it's pretty well-trodden. It's a well-trodden path. You define all the recipes that you have, you run the build, and at the end you get an OS image plopped into your build directory, and it's pretty much done, except that you might want to do things like OS updates. Security is a thing. Even if you have something that is a little bit more complicated than a single device or a battery of devices that get plopped somewhere and never updated ever again, that is quickly going out of fashion. Again, security is a thing. As soon as something is connected to the internet, you probably want to have a security policy in place. You want to have updates in place because new stuff appears every single time. And as I was saying, since Yocto is the Swiss Army bazooka, there are lots of options available to do OS updates. There's swupd, swupdate, Mender, OS3, Rauk. They're all supported-ish, but they're all kind of supported. If you go on the Yocto website, there is a list with pros and cons for each, and there are recipes on how they're integrated in the final result. But every single solution needs its own extra layers of dependencies, needs its extra space on the final image. Some of them may be big, some of them might be small-ish. If Rauk is implemented partly in Python, for instance, so it means that you need to get Python inside the end image. And that might not be something that you are willing to compromise on. Because then you have to update. Your security updates are now covering the update system. That's great. And every time a software engineer or computer scientist is presented with a problem of too many options, there's always an XKCD for everything. So how about systemd-sysupdate? If you're here, you probably know something about sysupdate, but again, just as a quick recap, Sysupdates gives you atomic updates. You can get an OS image from remote and local sources. You have A/B partitioning update style. The important thing is that it has a relatively small footprint on the final image. Like roughly, if you take the minimal image possible, it adds about like 5% more space. So the smallest possible the image is it's less than 50 megabytes. This one adds about 10. And it's also available in systemd. So it's already there. You don't have additional dependencies. It's part of the system. And it has a bunch of other additional features that are kind of interesting and kind of part of the reason why this would be a good choice if you only care about software updates, like OS updates on an image-based system. So how do you integrate sysupdate with Yocto? There are like 3 steps. It's kind of easy because it's already there, so you don't have to do a lot of work. I'll talk about some of the like weird edges that come out of the process like later on, but there are like kind of 3 steps. You set up a base OS image with everything that you need. You add a UKI, a unified kernel image, to the layout of your build, and you add version information to the OS image so that the systemd-sysupdate can determine whether or not you need an update. So, step 0, we need a POCI image. POCI, again, is the reference, kind of reference. It's not really, but like, for sake of discussion, is the reference distribution for the Yocto project. The slides have the file name at the top that they reference to, because at the end there is an example repository with all the files needed that you can use, and it will automatically build everything for you if you check it out on GitHub. These are a bunch of environment variables that are set up to set up the POCI image. Of course, we want to have systemd as the init manager. We want to have the systemd boot for the EFI bootloader. And the last part is the file that determines how we are going to partition the system. This one is an example of the recipe for enabling UKI inside the reference image, the reference example that we are using. Just some metadata configuration for the UKI command line. And then the last part is inheriting from the default recipes from Yocto that already provide most of this stuff. So the recipe itself is just configuration for the baseline. This is just a ton of gobbledygook for how we lay out the partition. The first one is the boot partition. The part type is an hash for the partition's discoverable partitioning specification that basically says, yes, this is EFI EFI compatible boot partition. And the second one is our root file system. Again, it's just a bunch of gobbledygook for the Anaconda. It's a Kickstart format. So after we have our image, after we have our base operating system image that gets built and it's done, it's ready for being installed. It doesn't have any update mechanism yet. We need to say, this is the image version. This is the version of the image that we are building. Again, this one is done by editing the OS release recipe, just appending a bunch of information there. What we want to do is add a field to the OS release file inside our etc directory. And we are just adding a new field there. They just, again, not very interesting there. We are going to set the image version inside our environment when building the operating system image. It's needed because we need to specify that, but it can be set by anything. It can be set like locally when you're testing it out, or it can be part of your CI pipeline, for instance. It's just an environment variable. And then we use that value to specify the name of the UKI file that we generate. So at the top, you can see we have a UKI image version, and the partition label on the command line for the UKI kernel contains that image version there. This allows us to parameterize the build. So at the end of the process, the build will have that particular the particular fragment that we are setting, and so on and so forth inside the Kickstart file for generating the partition. We add the name there. The underscore is convention, so it's used by systemd boot as a convention. And then, final step. We build systemd with sysupdate and sysupdate daemon enabled. These are not the default in the current base recipe for systemd on Yocto. So since we're building everything anyway, we can modify the build to include those components. And then if you have never seen how systemd sysupdate works, this is the mechanism that sysupdate uses to transfer the root file system from one partition to the other when updating. So it's using a simple A/B partition layout. You say the root file system is on partition A, download and install the update inside partition B, and the next boot transfer the boot to the second partition. And whenever you update, go back and remove the partition A, and so on and so forth. So if the boot succeeds, you always have an atomic swap to the next version. If the boot doesn't succeed, you have an atomic swap to the current version, and it doesn't break in the middle. An interesting part here is the match pattern here, which contains that @v. The documentation for systemd will tell you that that particular escape sequence will be expanded to the image version when it's needed. So the sysupdate will know which file needs to be used to do an update. And this tells you where the source file is going to be, the UKI file is going to be using the path there, and the match pattern there. Same for the UKI. It's exactly the same. Again, another bit of Yocto bit-bake recipe gobbledygook. We are just telling the system we're telling Yocto to create a directory and copy the files that are here into their final destination there. Again, this is the customization needed to make it work. And again, Kickstart. This partition here, the second one named _empty, is the target location for the next version. It's an empty partition that has the same size and the same partition type as the root file system, but it's called _empty, again, convention from sysupdate. Sysupdate will know to put the next version inside that partition. Of course, once you've done that, it's already done for your operating system. That's all that's needed. But how do you serve an update? So you really don't need anything more than a very simple HTTP server with the files that you're serving and the SHA-256 checksums of every single file, so that sysupdate knows, can do a check when it downloads to verify like integrity. And this is not DM Verity. There's no verification when it's done at the end. I'll talk about it later. This is just verifying the download, that the download is correct. So let's see if I can get a very simple demo. I'll walk you through it. This one is booting up the initial version. As you can see, it doesn't have anything there, just version 1. It's booting. And the OS release file that we modified has this image version here with 0, because that's the version that we are setting. If it's, oh, what is it doing? There you go. And these are the contents of boot. You can see image version 0 and UKI 0. And the update control command line, oh, that one went really fast. Sorry. Let me see if I can get. Video controls in web browsers. Let's see if I can get it done. Oh, this is Firefox being weird. Okay. As you can see, we are exporting image version 1. We are not doing anything. We're not rebuilding anything. It's just changing the version there. It doesn't do anything special. Just copying a pre-built image there, changing the checksums, and you can see there. And now update control says that we have an update. Uses get, we reboot, and now we have 2 versions there, 1 and 0. We boot 1, enter it, and now OS release as image version 1. You have to imagine a rebuild happened between 0 and 1, of course, but it works pretty much that way. Now we bump up to image version 2, do the same. We have an update. Reboot into image version 2. As you can see, 2 and 1 are still available. 0 is gone. Image version 2, and we have UKI1, UK2 there, UKI2 there. We can reboot back into version 1. As you can see, it's still there. But if you do update control check, it says there are no updates available because version 2 is already available, it's already installed. As you can see. Current protected here. We are booting here, but this one is available and it's current. So if you boot again, it will get into 2. So there are some limitations here. And it's, yeah. There are some limitations across the board. There are some limits that what you have available. First of all, it's a full OS image. So if you have limits there in terms of bandwidth, in terms of like in terms of connectivity and things like that, Delta updates would be a lot better, but unfortunately they're not available. There's some discussion going on, but still nothing ready. Yocto, the basic things work really well. Again, 3 steps, just a little bit. If you know Yocto, this stuff comes really easy, but if you don't, it doesn't take that long to get it. The main problem is that the advanced bits are kind of complicated. Like setting up the M-Verity for this is not super trivial. It's still something that Yocto hasn't finalized very well. You need to do a lot of like hand-holding there. There are some recipes available, but they're not great. But it's a work in progress. And the other problem is that, of course, this entire exercise depends on your target hardware environment supporting UEFI and supporting the ability to do systemd boot, which is not as common as I would like. A lot of embedded boards do not really support UEFI. ARM is trying to push it, but yeah, some stuff doesn't really work. You cannot get this running on a Raspberry Pi, for instance. Believe me, I tried. So there are alternatives in this regard. One is Rauk, another one is Mender. Same as systemd-sysupdate, they require changing a lot of the stuff in your build environment. So it is a decision you have to make early in the process. Otherwise, you'll have to like change stuff constantly. Since we are nearly there, this stuff is shockingly hard to find. There is no documentation whatsoever anywhere. So my colleague Martin wrote an entire tutorial on how to do this. The second link is interesting, is in French. You can pass it through Google Translate if you don't speak the language, and you will realize that the examples are wrong. You cannot. The general description is correct, but how it's implemented, it's wrong. And a generic overview of systemd-sysupdate is also available at the third link. And if you want to try out the demo, it's available. You can get it. There's a nice QR code there. Otherwise, it's available on the Igalia GitHub space. And yeah, thank you for your attention.
We can probably fit in a couple questions if you want to take them.
Yeah, sure.
But we will be on the heels of the next talk. So if you have any questions, there we go.
I'll try to be as quick as I possibly can.
Is the DM-Verity failure, if you hook it up, is that like a yes, no, I don't boot failure? Or can you make it so that, for instance, only some UEFI secrets are not unlocked if you don't pass the DM-Verity?
The DM-Verity bits right now are the straight up go, no go. Again, it's complicated. The DM-Verity support is not there. It needs to get there. Oh, there's a question over there.
Can this be used in a fully offline setting?
In theory, yes. Systemd-sysupdate allows you to sideload a file from anywhere as long as it's a path that is available or a URL or whatever. The main problem is you have to have access to, if it's offline, you have to have access to the actual physical entity. Also, the important thing, this is all works basically with connectivity or physical access. There is nothing there that deals with provisioning, remote updates, or anything. That is something that has to be built on top of this. Otherwise, it doesn't work. Yeah, that is a big thing. But yeah, other solutions have this capability or can be integrated in kind of this stuff. But they all require changes to how you build and how you set up your system. So they don't have the zero friction approach of sysupdate.